Okay, so today we are starting chapter 10, which is sequences and series. So first, let's start with a little vocab here. So our first is the word sequence. A sequence is an ordered list of numbers. So if you look at example A and B, example 1, A and B, those are sequences. It's a list of numbers. Now, each number in the sequence is known as a term. So if you look at example 1A, 32 is a term, 16 is a term, 8 is a term, and then the actual 32, 16, 8, 4, that is your sequence. Now, there's two different types of sequences. There is a finite sequence, which has an end to it, and then there's an infinite sequence, which does not have an end to it. So if you look at this example right here, 1, 3, 5, 7, 9, that is a finite sequence because it stops at 9. If you look at this sequence right here, 1, 3, 5, 7, that does not end, so that is an infinite sequence. Okay, so what we're going to start with is recognizing patterns. So it says find the next 4 terms of each sequence. So go ahead, pause the video, open up Notability, try to see if you can find the next 4 terms. You're looking for a pattern and then what the next 4 terms are. Okay, so on A, what you should notice is that in order to get the next term, you would have to take half of the previous term. Half of 32 is 16, half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1, half of 1 is a half, and then half of a half is a fourth. All right, go ahead and try the next one. All right, what you should notice here for this pattern, this is plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. So now to get my next term, I'm going to add 7, which is 29. I'm going to add 8, which is 37. I'm going to add 9, which is 46, and then add 10, which is 56. So there's my next 4 terms. Okay. Next, it says write the first 4 terms of each sequence. So what's going to happen is that they're going to give you an equation that the pattern follows. So this says a sub n is equal to double n. So on the first one here, I want to find the first term. That's what this a sub 1 means, find the first term. So what I'm going to do is I'm going to plug in 1 for n. That's 2. My second term, I'm going to plug in 2 for n. That's 4. And then you can see you get 6 and 8. So there's 2 ways of writing this. A sub 1 equals 1, or sorry, a sub 1 equals 2, a sub 2 equals 4, a sub 3 equals 6, a sub 4 equals 8. Or you can write it as a list. 2, 4, 6, 8. All right, next one. We have b sub n is equal to 4 times n plus 2. So when I want to find b sub 1, I'm going to plug in 1 for n. 4 times 1 is 4 plus 2 is 6. b sub 2. 4 times 2 is 8. 8 plus 2 is 10. b sub 3. 4 times 3 is 12 plus 2 is 14. And then b sub 4. 4 times 4 is 16 plus 2 is 18. Okay, so one thing that we want you to notice is that there's a pattern in both A and B. So if you look here, if I said, how do I go from the first term to the second to the third to the fourth, can you complete the pattern without knowing right now what the equation is? You'd say, yeah, it's 10, 12, 14, 16, 18, so on and so forth, because all that you're doing is adding 2, right? You're adding 2. Plus 2, plus 2, plus 2. If you notice, what's happening here is this right here is a multiplier of 2. Or like if this was an equation of a line, that'd be this slope. So if I need to increase a function by adding or subtracting, that would be a multiplier in my equation. If you look right here, same idea. This is plus 4, plus 4, plus 4. My multiplier is 4. That is something that will happen every single time if it's addition or subtraction with a constant number. All right, let's move on to the next one here. So let's find c sub 1. So I'm going to plug in my exponent of 1. 5 to the first power is 5. C sub 2, 5 squared is 25. C sub 3, 5 cubed is 125. C sub 4, 5 to the fourth power is 625. All right, so now if you look at the pattern here, this is plus 20, but this is not plus 20. So what you should notice instead, this is times 5, times 5, times 5. So when you have a multiple, so when it's increasing by a multiple of 5, you're going to have an exponential function where the base is 5. So if I saw something increasing by a multiple of 3, so times 3 times 3 times 3, exponential function with the base of 3. If you look back at our first example, my computer just froze, sorry. Let me get my Notability back up here. I'm not going to start over, I refuse to. But if you look back at our first example, where it was half, this would be an exponential function with the base of 1/2. Okay, let's look at this next one here. I have d sub 1 I need. I need to plug in 1 here and here. So I have -1 to the first power, which is -1. And then I need to plug in 1 here also. 1 plus 4 is 5. So d sub 1 is -5. D sub 2, I'm going to plug in 2 right here. -1 squared is +1. And then plugging in 2 there, 2 plus 4 is 6. So I get +6. D sub 3, plug in a 3 here. -1 cubed is -1. Plug in a 3 here, I get 7. So d sub 3 is -7. Last one, d sub 4. If I plug in a fourth power here, I get a +1. 4 plus 4 is 8. So I get d sub 4 is 8. All right, so if you look at what's happening here, first off, if you ignore the positive and negatives, each term is increasing by 1. So +1, +1, +1. That means I have a multiplier of 1, and you do. Notice the slope of that line, if you look at it as an equation of, it's 1. Now it's also changing signs. It's going negative, positive, negative, positive. So to get something in a pattern to alternate by sign, you would need to have -1 to the nth power, or possibly -1 to the n minus 1 power, or -1 to the n plus 1 power. But that -1 to a power is what's going to make you alternate signs. Okay. Next part, super easy. It gives you an equation to follow. It says a sub n is equal to n divided by n plus 2, and then it asks you for 3 individual things. So first off, find the 9th term, so a sub 9. All that means is plug in 9 for n. 9 over 9 plus 2, so 9/11. Next one, find the n minus 1 term. So a sub n minus 1. So just like we plugged in 9 for n here, we're plugging in n minus 1 for n. So we're going to plug in n minus 1 here and here. So I get n minus 1 over n minus 1 plus 2, which is n minus 1 over n plus 1. Same idea here. My Notability keeps freezing. Just exit out of it again. Same thing on that one there. You're going to plug in n plus 1, so a sub n plus 1. Plug in n plus 1 into the numerator, and then n plus 1 plus 2. So that becomes n plus 1 over n plus 3. Okay, next we need to talk about recursive formulas. So sequences can also be defined recursively. So this is when you're given either the first term or the first and second term, and then it's giving you a pattern that it's following using that first and or second term. So things you need to know before we start this is that when I talk about a term, that's a sub n. Okay, if I want to talk about the term before that, that's a sub n minus 1. So this is the previous term. If I want to talk about the term before that, that's a sub n minus 2. If I want to talk about the term after the term I was talking about, it's a sub n plus 1, and then so on and so forth. Okay, so what's really important is just knowing that a sub n minus 1, really what you should be saying is the previous term. Okay, so it says each sequence is defined recursively where n is greater than or equal to 2. Find the first 5 terms of the sequence. So in this one here, I start off by telling you the first term is 3. So at least I got my list started. But I need the second term, the third term, the fourth term, and the fifth term. Okay, so it tells you how to get the next term here. This is your recursive formula right here, telling you how to get the next term. So to get my second term, a sub 2, it tells me to take 4 and then subtract. Remember what this means. It means the previous term. So the previous term to a sub 2, which is a sub 1. So I'm going to subtract the previous term, which is 3. And I get 1. So my second term is 1. Now to get my third term, I'm doing 4 minus. And then once again, this means the previous term. The previous term is 1. 4 minus 1 is 3. To get my fourth term, I'm doing 4 minus the previous term, which is 3. So I get 1. To get my fifth term, 4 minus the previous term, which is 1, so I get 3. So there's my first 5 terms of my sequence. Once again, if you know how to read this in English, instead of looking at it as written as a mathematical equation, it makes it much easier. All right, let's look at this next one here. My first term is 64, and then I have to know how to read this right here. So it says take half of the previous term to get the next term. So this one I can do absolutely no work and come up with it. To get this term, I'm going to take half of the previous term, 32. To get this term, I'm going to take half of the previous term, 16. 8, 4. All right, so C and D are a little different because they give you the first 2 terms, which in my brain says, hey, less work. So that's what I'm going to look at it as. I know the first term's 3, the second term's -1. So now I just need the third, fourth, and fifth term. Okay, so I'm going to use the recursive formula to help me here. So I'm going to write down work for this because it's a little more complicated clearly. So it says take 2 times, what does this mean right here? The previous term. So the previous term to a sub 3 is a sub 2. So that's -1. Plus, what does this mean? 2 terms before that term. So 2 terms before a sub 3 is a sub 1. 3. 2 times -1 is -2 plus 3 is 1. Now I need a sub 4. All right, once again, make sure you're reading this correctly. Take 2 times the previous term. 2 times my previous term, 1. Plus the term 2 terms before that. The two terms before a sub 1 is a sub 2, so -1. 3 plus -1, 2. Okay. Oh, sorry, that's 2 plus -1. My bad. 2 plus -1, 1. That could have been bad for me in my next one if you get something wrong. All right, a sub 5. 2 times the previous term, which is 1, plus the term 2 terms before that. So the term 2 terms before a sub 5 is a sub 3. So that's 1. 2 times 1 is 2, plus 1 is 3. And there's my sequence. All right, go ahead and pause the video, go to Notability, and try this one on your own. All right, I know my first 2 terms are 1 and 1, and then I need my last 3 terms. So once again, I have to be able to read my rule. I'm finding my third term. This says take the term 2 terms before that term. So 2 terms before a sub 3 is a sub 1. That's 1. Plus the previous term. The previous term is 1. So I get 2. A sub 4, take the 2 terms before that, so that's a sub 2, which is 1, plus the previous term, 2, 3. A sub 5, I want the 2 terms before that, so a sub 3, which is 2, plus the previous term, which is 3, I get 5. And there is your sequence. Okay, next what we have to talk about is this one says, find the sum of the first 4 terms of the sequence. So first off, let's find the first 4 terms. Let's find a sub 1, a sub 2, a sub 3, and a sub 4. Once again, you can write it like this, or you can write it as a list. All right, so we are going to plug in 1 through 4 into this equation right here. All right, plugging in 1, we get 3. Plugging in 2, we get 4. Plugging in 3, we get 5. Plugging in 4, we get 6. You could have also said, oh, this is a multiplier of 1, so I'm going to add 1 to get each additional term after I get my first term. All right, now the only difference on this one says it says find the sum. So we're going to do 3 plus 4 plus 5 plus 6, which is 18. Okay, so this sentence right here can be rewritten mathematically, and this mathematical way of writing this means find the sum of the first 4 terms of the sequence a sub 1 equals n plus 2. We can write this in sigma or summation notation. All right, so let's do that really quickly. So in order to write in sigma or summation notation, first thing you need is a sigma. It's the Greek letter of the alphabet. Sigma, that's a capital letter. All right, to the right of your sigma goes your expression of what your pattern is following. So this equation was given to us, so that is nothing that we have to actually look for right now, which is n plus 2. So you're going to write n plus 2 right here. All right, down here you write down where n is equal to, and then you're going to say what you plug in to get your first term. Well, we found our first term, so we plug in 1 to get our first term, which was this 3 right here. Then it's going to say what's the last term you're plugging in. We're plugging in the 4th term, so that's the last term we'll be plugging in. So this right here says and plug in 1, 2, 3, and 4 into this expression and then add them all up. That's what this means right there. Okay, so that's just reiterating what I just said. So now what we're going to do is we're going to write each of these using sigma notation. So for each of them, I'm just going to start off by writing a sigma, because I know that in order to write in sigma notation, I need a sigma. All right, so I need the pattern that they're following, and I need to write it right there. Okay, so what I'm going to do is I'm going to look to see what pattern's being following here. Also, I know it's sigma notation because it's plus, 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 because I'm adding up all my answers, or I'm adding up all my terms. Okay, let's look for a pattern here. Plus 2, plus 2, plus 2. That's the pattern. And then it's going to go all the way up to 30. So 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14, so on and so forth. Okay, so now remember, if it is a plus 2, that does not mean n plus 2, because this means that it is going up by 1, if anything. Instead, remember, that means that there's a multiplier of 2. So my equation I'm going to start with, or my expression I'm going to start with, is 2n. All right, now I might need to add 5 to this or subtract 6 from it. I might need to mess with it, but as of right now, I'm just going to check to see what happens when I plug in 1. So if I plug in 1 here, do I get this first term? If it is, then the expression is good to go and it's ready. So if I plug in 1 there, do I get 2? Yes. All right, now I need to know what I'm putting up here. So this is what do I plug in here to get my last term. So the most common mistake people make is they'll put a 30 right here. But if I plug in 30 there, I get 60, which is not my last term. So what do I need to plug in there to get 30? I need to plug in a 15. So now you can see that this is your sigma notation. Now, if you had trouble getting that 13, or if it's more complicated later, you could always take your expression, which is 2n, and set it equal to your last term, which is 30, and solve for n, and you get 15. Then you know your last term's 15. All right, on to our next one here. I don't like how close my sigma is to that, so I'm going to move it down a little bit. All right, this time I noticed that I have fractions, okay? 3 of the 4 are fractions. The first one's not a fraction. So the first thing I want to do is I want to make the first one a fraction just so that, by putting it over 1, just so that I can say, okay, now they're all fractions. Whenever you're dealing with fractions, you want to look at the numerator and the denominator separately. Look for a pattern in the numerator, look for a pattern in the denominator. So let's start off by looking for a pattern in the numerator. They're all ones, so 1, that wasn't very difficult. Let's look at the denominators now. Okay, so how do I get from 1 to 3 to 9 to 27? Times 3 times 3 times 3. So now remember, if there's a multiplier of 3, that does not mean 3n. That means it's an exponential function with a base of 3, and then your exponent is going to be n. Now we can change that exponent to n minus 1 or n plus 1 based on what we're saying we're plugging in first. So I'm going to say where n is equal to, and I'm going to start by saying that I'm going to plug in 1. So now I have to test it. If I plug in 1 here, what do I get? I get 1 over 3. Is 1/3 my first term? No, it's not. So I have a couple options here. I can either change the expression. I can try to mess with this. Or even easier, I can mess with this. I can say, okay, well, I don't get 1 when I plug in 1. So what's going to make me get 1? So what I'm going to do is I'm going to go less than that. So I'm going to plug in 0. Let's check that. If I plug in 0. If I plug in 0 there, I get 3 to the 0. What's 3 to the 0? 1. I get 1 over 1. I get my first term. So that's my first term. I'm going to say I'm going to start with n equals 0. All right, now I'm going to look for my last term, and I say there is no last term. This goes on forever and ever. So if it goes on forever and ever, you're going to say that it goes on through infinity. This is not the only answer, okay? These all have an infinite amount of correct answers, but usually that we come up with either 1 or 2 of the same answers. All right, last but not least, right now this says write out and compute each sum. If you saw this on a standardized test, it doesn't need directions to go with it because this is signal notation. Like if I just saw this problem by itself, I know that B says plug in 3, 4, 5, and 6. Once you get those terms, add them all up when you're done. So that's what you're going to do with these problems. So let's start with B actually, because I think A is a little bit more confusing if you don't do B first. So we're going to plug in 3, 4, 5, and 6. Now I'm writing these small and I'm putting them there just so I don't get lost. All right, let's start by plugging in 3 here. 2 times 3 is 6. 6 plus 3 is 9. Now I'm going to plug in 4. 2 times 4 is 8. 8 plus 3 is 11. Plug in 5. I get 13. Plug in 6, I get 15. Now, you could have kept going, like plug in 6, plug in 5, or once again, you can see that there's a multiplier of 2, so each number is increased by 2. All right, this is not your final answer because this is sigma notation. It's find the sum. Add these 3 numbers together. 9 plus 11 is 20, plus 13 is 33, plus 15 is 48. So my answer is 48 here. All right, let's go back to the first one here. So this is you're plugging in 1 through 7. 1, 2, 3, 4, 5, 6, and 7. All right, let's go ahead and plug in 1 for n. I go to plug in 1 for n, and there is no n. I get an automatic output of 5. So I always get an automatic output of 5. But then I have to add those all up. 35. Now some of you might be saying like, oh, can we just put down 35? Write out and compute. So on this one, no. All right, here we're plugging in 0 through 5. 0, 1, 2, 3, 4, and 5. All right, let's start off by plugging in 0. We have to plug in 0 into 2 places. I have to plug it in here and here. So I'm going to get 2 things, and then I'll multiply those to get my final answer. All right, -1 to the 0 power is 1. Anything to the 0 power is 1. And now I'm going to plug in 0 for that exponent. So 0 plus 1 is 1. 2 to the first power is 2. 1 times 2 is 2. All right, now I'm going to do the same thing here. Plug in 1. -1 to the first power is -1. 1 plus 1 is 2. 2 squared is 4. So I get -4. Now I'm going to plug in 2. -1 squared is +1. And now I'm going to plug in a 2 right here. 2 plus 1 is 3. 2 cubed is 8. All right, so now I have 3 more numbers to plug in, but I'm saying, wait a minute, there's a pattern going on here. Positive, negative, positive. This is going to be negative. This is going to be positive, and then that one will be negative. I know that's happening because of this negative 1 to the nth power. What's the other pattern that's going on? And this time you can disregard the positive, negative because we already talked about it. 2, 4, 8. What's that pattern? It's doubling. Why is it doubling? Because there's an exponential function with the base of 2. So I can get these numbers now. This is 16. This is 32. This is 64. Yes, you could continue the way that we were doing it and get those answers, but this is faster if you just think about the pattern. All right, last thing you have to do is add all of these up. 2 and negative 4 is negative 2, plus 8 is 6, plus negative 16 is negative 10, plus 32 is 22, plus negative 64 is negative 42. All right, that concludes today's notes. Please go ahead and get started on your homework.